So in the previous problem, we calculated the Z value, which is Z naught, as 2.648. That was the value. And the level of significance as per the problem was 0.05. But remember that this level of significance is not our p-value. I'm going to calculate the p-value in our case. We already know the p-value formula. For the sake of clarity, I'm going to repeat the formula once again. I'm going to write the formula for this session so that it remains in front of you. For case 1, where we considered two-tailed test, the formula is 1 minus 2, 2 into 1 minus phi z0. This is the formula. For case 2, we have got two formula. Case 2 is one-tailed. So we have got the formula for right-tailed and left-tailed. For right-tailed, the formula is 1 minus phi z0. For left-tailed, the formula is phi z0. In our case, we assume the null hypothesis to be P1 is equal to P2. And our alternative hypothesis was P1 not equal to P2. And that was indeed a two-tailed test. No doubt about it. So to calculate the p-value, we are going to stick to the formula 1. So the p-value is calculated as 2 into 1 minus phi of 2.648, because you know my z0 is 2.648, so it is 2.648 I'm writing. And by the definition of phi z, as I told you in my previous session, that it is the notation for this probability. So I'm actually writing this as 1 minus probability of twice 1 minus probability of z less than or equal to 2.648. Okay. Let me check, save your chat. Okay. Now I'm going to calculate this particular probability by using the normal table that I shared with you in class note. And if I try to find out the probability over there, probability of this particular term from the normal table, it comes out to be, let me check the table. .9959. And if I calculate this probability, it is 0.0082. Now, by definition of p-value, we already know that it is the lowest level of significance. Lowest level of significance at which H naught will be rejected. Okay, so let us call this level of significance to be say alpha 1. If we now choose our alpha to be 0.05, this is definitely greater than alpha 1. If I choose alpha to be 0.01, it is definitely going to be 0.0082. If I choose my alpha to be this, it is definitely going to be greater than alpha. Sorry, it is alpha 1. If I'm choosing my alpha to be 0.50, it is also greater than the alpha 1. So at all of these level of significances, at all of this level of significances, your H naught will be rejected. So we have got the lowest value at which the null hypothesis will be rejected. But if someone selects the alpha to be something like say 0.007, if this is somebody's alpha, somebody's level of significance, then you know that in this case alpha is less than alpha 1, and this implies at this level of significance H naught is accepted. So we have to know the boundary at which this that will tell us that critical value, this particular level of significance is giving me not a critical value, it's a probability of the critical value at which the null hypothesis will be rejected. And if you consider any level of significance greater than that, then your null hypothesis is obviously going to be rejected. Now, diagrammatically, if we want to measure the thing, what is happening over here? So suppose I'm going to draw the diagram once again. And as I told you that for some Z naught, we actually got this probability, say 0.0082. For some Z naught, we have got this probability 0.0082, isn't it? Now that Z naught is if this probability is the probability of the critical value, then question is, what is that critical value? What is that critical value? So we can calculate the critical value corresponding to p value also. How this can be done? Let me show you. Now we want to calculate the probability that for some number Z1, when the random variable lies between minus Z1 and plus Z1, what the probability becomes 0.0082. We want to know what is this particular value. What is this particular Z1? We can easily calculate this probability using the normal table. If I consider the Z1 to be here, it is minus Z1. And if I consider another Z1 to be there, okay, and we are interested in finding this probability, then this can be done. We know very well that this can be written as Z lying between 0 and Z1. The half of this not half, actually, it is the twice of that. Twice of this probability is actually going to be your 0.0082. This is the probability, because twice of this portion is equal to the total one. Why? Because it is a normal curve, it is symmetric. This portion and this portion, they are same. This portion plus this portion gives you the total. So twice of one half of the portion gives you the total probability of this one. Now we want to know for what value of Z1, this happens. Now from there we can easily calculate the probability, this 0.0082, which is half of that. And this probability is coming as 0.004. Okay. And we want to find out now the probability. Say we want to find out the probability of z less than or equal to less than z1, so that we can use the normal table. Now we know that if I'm interested in this particular probability, it can be written as, this probability can be written as, probability of, when I write the probability of z less than z1, that means the entire part on the left hand side of z1 is being considered. Now this is obviously equals to probability of z less than 0 plus probability of z lying between 0 and z1. If I add these two figures, if I add these two probabilities, we'll get the left hand side. You can check in the figure. This portion and that half of the portion together gives you this probability. Now this half, probability of z less than 0 is 0.5 because it is the normal curve. And this we have already calculated, it is 0.0004. So we get what? 0.5041. So this probability has come out. Now you go to the normal table. If you go to the normal table, try to locate the quantity which is called 0.5041. I can see the normal table in the class note 8. I can locate this particular value. Exactly 0.5041 is not there. I'm able to locate the 0.5040, and the next point is 0.5080. So I'm considering the 0.5040, and for this I'm actually getting the z as from normal table. I'm getting my z1 as 0.01. So if you can select here, what does this mean? That this, if you can select your sample in such a manner so that your calculated value of z, if you can select your sample in such a manner that your calculated value of z comes out to be 0.01. Remember, this particular 0.01 is not level of significance. Although we have got to see kind of level of significance like alpha equal to 0.01, this is something different. This is alpha, and that thing which I'm doing over here, it is z, the value. Okay, so it's not a level of significance. Remember, don't just confuse yourself. So you have to select your sample in such a manner that your calculated value of z gives you 0.01. If I get such a sample, such a thing, then I can assume that 0.01 minus 0.01 on the left hand side and plus 0.01 on the right hand side. And then I can say that corresponding to that sample, there is a kind of chance that my null hypothesis will be accepted in this particular region. So we have to do it very cleverly by selecting our sample size accordingly. Now you can ask me this question: can I decide in advance what should be my sample size for getting this kind of value from the test statistic? The answer is yes. If you can manipulate the thing from one direction, you can manipulate the thing from the other direction also. It is helping you out to find out with the help of the p-value. It is giving you a kind of, after following this particular direction, you are reaching to this particular z1. So using this Z1, you can ultimately reach to a situation where you can decide about your sample size. Okay. So in newspaper, we have often seen that data are given, conclusions are given in short, but they never mention, they sometimes mention the sample size, but the sample size they are mentioning, it is often prone to mistakes, intentional or unintentional. So for the same situation, in different newspapers, on the basis of the same situation, we get different conclusions. Some newspaper is saying that nowadays in Kolkata, the second wave of COVID-19 is in declining direction, is declining. And in some newspaper, we are getting that it is increasing. So we actually, the people, the common man actually do not know what to believe and what not to believe, when to believe and when not to believe. So it is better if I can get hold of the data. Let's do the calculation by ourselves to get our own vision of the situation. So the main thing is that when I solve this particular problem without using p-value, we got the same conclusion. And we are happy to see that our p-value approach is yielding the same result. But why to decide this level of significance in advance? The deciding level of significance in advance is not generalizing the situation. Okay, so if I want to get a good amount of information about the data, then we have to be open-minded. We have to find out the lowest level of significance at which the lowest level of significance which would lead the rejection of the null hypothesis. And on the basis of that, keeping that level of significance in mind, we can tell at what level of significance is this null hypothesis is going to be rejected or not. So we are actually doing some sort of manipulation with while drawing the conclusion. Now you can ask me this question, whether this kind of manipulation is acceptable or not. Okay, if I can say that when I'm saying that this p-value is 0.0082 and you are writing these cases that at this the null hypothesis will be rejected, then someone mathematically can ask you why aren't you considering this particular case? What is the problem with that? Okay, so there is a problem. There is a problem with that because you see the deviation here is actually very poor, and we know that in statistical hypothesis problem, a Six Sigma chart is often considered to be very useful. So the deviations are here. My intuition says that if I do the calculation and try to find out the sample size, then the sample size will be kind of very small in this case. A small samples, that large sample problem will become a small sample problem. So that's why there are some other reasons for which it is not done. General opinion in the community of statisticians is that they often like to stick to this level of significance and that level of significance. Okay, but if you ask me why, I do not know that. I do not know this, why they like to stick to that. There is no logic that has become kind of universally acceptable region, maybe because of the confidence limit section. Because you see, whenever you can say this thing, that whenever you are saying that this is my acceptance region, your confidence limit is very poor, you see. If this is your acceptance region, your confidence limit is very poor, very low. But your rejection region has high probability. So the rejection region is very large, but we want to expand the acceptance region. We don't want to reduce the acceptance region. And therefore, will not never consider the level of significance which is less than 0.0082. we'll keep on increasing the level of, we can take 0.009, 0.100 like this, gradually keep on increasing that value. Okay, and if I do so, our size of the acceptance region will keep on increasing. Okay, so although, and it is also very, important to notice that if I write this to numbers -3 and +3, this is the 3 sigma range. This is the 3 sigma range. Okay, and because -3 stands for mu minus 3 sigma, and this stands for mu plus 3 sigma. This -3 is coming corresponding to Z, mu minus 3 sigma is coming corresponding to X. If I add these two figures, if I find the difference between the two points, so mu plus 3 sigma minus mu minus 3 sigma will give you 3 sigma plus 3 sigma, which is called 6 sigma. So this is actually the 6 sigma chart. We are actually in 6 sigma chart, this acceptance region is too high, and the confidence limit is how much? It is 99%, 99.73%. This confidence limit is 99.73%. So by 99.73% confidence, you can say that I'm accepting my null hypothesis, and the rejection probability is very poor. The rejection probability is 0.0003, like this. Now, our calculation actually falling in this 6 sigma chart, but since it is falling in the 6 sigma chart, immediately we cannot conclude that, yeah, I'm going to accept it always. That's why in the previous approach, I told you that whenever it is Z, whenever mod Z is greater than 3, that is when Z is less than -3 or Z greater than 3, we can definitely say that I'm going to reject my null hypothesis. But if the Z value is falling between -3 and +3, then we accept the null hypothesis for the time being. And we say that further analysis at different level of significance is actually very important. So that's why we do this kind of thing. This is the main mathematics behind it. Okay. Now, up to this, I have opened the chat box. So up to this, if you have any doubt, you can write in the chat box. You can ask me in the chat box, or else I will proceed with something else. You want to ask me question, then you can write in the chat box. There is another case. So what sort of cases we have done in hypothesis testing large sample test? We have done test of significance of single proportion, test of significance of difference of proportion, test of significance of single mean, test of significance of difference of means. There is one another testing. I can consider this to be case number 5. It is known as test of significance of difference of standard deviations. Difference of standard deviations. That is another case. And in this case, the Z value, the test statistic, capital Z, is defined as small s1 minus small s2 minus sigma 1 minus sigma 2 divided by sigma 1 square by twice n1, sigma 2 square by twice n2 under square root sign, where sigma 1 is the population standard deviation of sample 1 of size n1. No, sorry, not sigma 1, S1 I'm talking. Sorry. S1 is the sample standard deviation of sample 1 of size n1. S2 is the sample standard deviation of sample 2 of size n2. Sample 1 is drawn from population 1 with standard deviation sigma 1. Sample 2 is drawn from population 2 with standard deviation sigma 2. These are the meanings of this thing, and with the help of this we can calculate the required Z value, and we can decide on the level of significance and whether to accept or reject our null hypothesis or not. So here is a problem. Random samples drawn from 2 countries gave the following data. Okay, relating to the heights, of adult males. The data is as follows. Country A and country B. Mean height in inches, which is 67.42 and 67.25. Standard deviation in inches, 2.58, 2.50. Number of samples, 1,000 and 1,200. Question is, number 1, the question has 2 parts. Is the difference between means significant? Number 2, is the difference between standard deviations significant? So in this problem, actually there are two two problems are actually two different problems have been put inside a single problem. I'm not going to solve the problem, but I'm going to explain what to do about it. First of all, just look at this. These are the two samples of the countries. The mean height, that means x1 bar is given to you. X2 bar is given to you. Standard deviation is actually the sample standard deviation. S1 is given to you. S2 is given to you. These are the sample sizes. Now the question is, the first question is the difference between the means significant? What is this mean? Which is what is not mentioned over here is the word population. The question is the difference between the population means significant? And here it is written whether the difference between the population standard deviation significant. So for the first case, you have to do the calculation. For case number 1, problem number 1, you have to go for test of significance of difference of mean, and in 2 you have to go for test of significance of difference of standard deviation. So two different tests that you have to apply over here. Your null hypothesis will be, in this case, in the first test, you will consider your null hypothesis as, in short, mu1 equal to mu2, and your alternative hypothesis will be mu1 not equals to mu2. You are actually saying that there is no significant difference between the population mean, and your test statistic is actually will be given as x1 bar minus x2 bar by sigma 1 square by n1 plus sigma 2 square by n2. Okay, this is your test statistic, which comes from the formula x1 bar minus x2 bar minus mu1 minus mu2 sigma 1 square by n1 plus sigma 2 square by n2. But here you see, since we have assumed that mu1 equals to mu2, this term will vanish. Under the assumption this will vanish. And since sigma 1 is not known and sigma 2 is also not known, we are going to estimate sigma 1 by S1, and we are going to estimate sigma 2 by S2. And thus your Z will become x1 bar minus x2 bar divided by S1 square by N1, S2 square by N2. Okay, now all the information regarding these terms you have with you. Either you are going to accept the null hypothesis or you are going to reject the null hypothesis. I will say that apply p-value approach. Apply p-value approach over here. Here, in this case, you are going to set another null hypothesis and you are going to say that there is no significant difference between the population standard deviations. Your alternative hypothesis H1 prime will be sigma 1 not equal to sigma 2. So this is also a two-tailed test. Okay, so under H0 prime, your Z is given by the formula which I have written over here, this formula. But since you have mentioned that sigma 1 and sigma 2 are same, so under this your formula becomes S1 minus S2 sigma 1 square by twice N1 sigma 2 square by twice N2. But again here, sigma 1 and sigma 2 are not known. So this particular formula will be approximated by or estimated by the following. In place of sigma 1, we are going to put its estimate. In place of sigma 2, we are going to put its estimate. And thus your formula becomes S1 minus S2 by S1 square by twice N1 plus S2 square by twice N2. Now apply p-value approach over here also. So on the basis of the p-value approach, you are going to accept it or reject it. So what are the situations that you can obtain from here? The situation here will be, we have these two cases, 1 and 2, accept and reject. So what can you do? Can we what results can be obtained from here? We are accepting 1 and we are accepting 2 also. This may happen. Or what can happen? Rejecting 1, rejecting 2, both. Or you are accepting 1 but rejecting 2, or you are rejecting 1 and accepting 2. These are the 4 cases that may come from here. Now, since this particular problem is the problem which are part of the original one, this is the original problem, and these are the 2 parts. Okay, so therefore we are in the final conclusion. Final conclusion will be based upon the, or we can say the acceptance in the final conclusion will be based upon if both 1 and 2 are accepted. If we see that in both the cases, then this is also being accepted and this is also being accepted, then we are going to accept the final, we are going to write the acceptance in the final conclusion. If we get that both of them are being rejected, we are going to write in the final conclusion that they are being rejected. And if we are actually finding that partial thing, 1 acceptance, 1 rejection, then we have to accordingly write it specifically that in this case we are getting acceptance, in another case we are getting the rejection. So this is the way by which this problem can be done. Now I don't have anything further to say in today's class. If you have any question, you can write in the chat box. I'm going to stop the recording.